This is an extremely concerning quantum leap forward. This team has figured out how to turn cells into quantum processors, pushing us toward transhumanism. Researchers have pulled off a feat that should take 20 million years, yet they crushed it in just 15 minutes. This isn't sci-fi, it's the first verified quantum superiority using photons, set to flip our understanding of computation, intelligence, and existence upside down. This breakthrough I'm unveiling marks a seismic shift in what's possible, making today's AI boom look trivial. If we're meeting for the first time, welcome to the DarX-Files. Let's dive in. Scientists from the Technical University of Denmark dropped a bombshell in Science magazine. Using entangled photons, real quantum wizardry, they tackled a computational challenge that classical computers would slog through for 20 million years. They nailed it in 15 minutes. Let me break this down, because this is the kind of leap that splits history into before and after. The Danish team used a quantum computer to map a chaotic quantum system, decoding the workings of a mind-bendingly complex mechanism. Classical tech hits a wall here. More complexity means exponentially more data points, ballooning into the impossible. But quantum rules shatter limits. They created two streams of linked light. Picture entanglement as particles so tightly bound that measuring one instantly reveals its twin's secrets, no matter the distance. Einstein called it spooky action at a distance. However, Tesla's electric universe model calls it the ether. One stream probes the system, the other serves as a reference. Analyzing them together uses their connection to cancel out noise, pulling far sharper data from each scan than classical methods could ever dream of. This isn't just faster, it's a whole new game. Think of it like solving a puzzle piece by piece versus assembling the entire picture in a single step. Professor Ulrik Lund Andersen, the lead researcher, calls this the first confirmed quantum advantage in photonics. What's thrilling and chilling? They did it with standard lab optics in a basement setup. This changes everything. Beyond faster chips, we're stepping into uncharted powers that didn't exist until now. Imagine AI training. It currently guzzles massive datasets and insane computing power. Now picture entanglement slashing those times by unthinkable margins or sensors. Envision detecting materials, diagnosing diseases, or monitoring environmental shifts with unmatched precision and speed. But this slides into awe-inspiring yet deeply troubling territory. A team at the University of Chicago has revealed bioqubits, using glowing proteins like those in jellyfish. This lets them embed quantum sensors directly in living cells. To be clear, they're turning cells into quantum processors. These bioqubits detect magnetic and electric signals at nanoscale inside cells. By using natural proteins, they bypass the need for freezing temps and isolation typical in quantum gear. This could revolutionize medical diagnostics and biological research. But hold up, proceed with caution. Merging quantum tech with organic systems treads on sacred ground. It's not just better tools, it's meddling with life's core, built with flawless precision. The quantum forces driving these miracles could disrupt living systems in ways we can't predict. Think about encryption, financial modeling, drug discovery, climate analysis, any field relying on complex simulations. But wiring quantum into cells pushes us toward transhuman territory, redefining what it means to be human. Co-author Jonas Nergård Nielsen from the Computational Breakthrough shared a chilling insight. Our biggest thrill is finding a quantum system doing what no classical one could match. Think about that, completely beyond classical limits. Extending this to biology isn't just a power-up, it's risking life's essence. Zooming out, this keeps me up at night. This is just the beginning. These are lines we might be wise to leave uncrossed. Quantum theory is no longer abstract. It's becoming tools fused with biology. The computational feat used basic light gear, while jellyfish proteins now create quantum probes in cells. And another earth-shaking shift ramps up the unease. Paris-based startup Alice & Bob unveiled qubits lasting over 60 minutes. For context, standard qubits collapse in microseconds. IBM's best quantum rig hits 400 microseconds. Alice & Bob's breakthrough is millions of times longer. Let's pause for a moment to reflect. Combining computational wizardry that solves eons-old puzzles in minutes, with qubits lasting hours and bioqubits in cells, isn't just progress. It's rewriting the line between machine and life. Current quantum machines mess up every 100 steps, compared to classical ones erring once per quintillion. Fixing this needs tons of physical qubits for a few reliable logical ones. But hour-long qubits cut that need by 200 times, slashing costs and simplifying builds. Pair this with bioqubits, and you get tech that doesn't just compute. It merges with existence. We're at a point where wisdom must outpace invention. Quantum's unlocking powers could disrupt perfectly crafted biosystems. We're heading where human-machine, organic-synthetic lines blur. AI's rapid rise. Quantum's on a similar track, but the stakes are higher, especially with biofusion. Systems solving million-year riddles in minutes, holding states for hours, working in cells. This isn't an upgrade. It's a total rewrite of humanity. For entrepreneurs, investors, or career planners, pay attention. We're witnessing quantum synergies birthing the extraordinary, demanding serious caution. The computational superiority shows quantum tackles what classics can't touch. Stable qubits make it practical and cheap. Bio-advances weave it into life and the very fabric of all existence. Alice and Bob aim for 100 logical qubits by 2030, enough to disrupt materials science, create new batteries, improve solar tech, maybe even ambient superconductors to boost classical computing. Early adopters of this fusion gain edges competitors can't match classically. But bio-implications scream for restraint. Wiring quantum into cells ventures into more than transhuman zones, risking the natural balance life itself, every plant animal, and every known biological species and more. This isn't just tech, it's existential questions about human purpose. Turning cells into quantum sensors dazzles for diagnostics, but it's a profound rework of life's design. Should we fuse quantum with biology just because we can? This dwarfs the internet, smartphones, AI. This quantum leap reshapes not just computing, but our very being. The real question? Can we navigate these shifting sands without losing our essence? Tomorrow is being built in labs today. While the masses obsess over new AI or apps, quantum pioneers crack cosmic secrets, ready to implant them in cells. 15 minutes against 20 million years. Hour-long qubits over microsecond flickers. Cellular quantum sensors. This is an existential overhaul. By 2030, just years away, error-corrected quantum with 100 logical qubits could conquer materials, medicine, and codes untouchable by classics. Yet it signals the dawn of tech biofusion. We stand at a crossroads needing balance between ingenuity and wisdom. The brilliance weaving life systems should guide our quantum push. The question isn't if quantum changes everything, it's will we protect our core essence. Here's something to chew on. 99% of scientists create with good intentions, aiming to help humanity. Then the military-industrial complex swoops in, and history shows these breakthroughs get twisted into tools of dangerous consequence. Subscribe to lead the charge in redefining what's possible, and join the vital debate on navigating this ethically. When quantum computation, stability, and biofusion collide, everything changes. Comment below. How would you use tech that cracks 20 million-year puzzles in 15 minutes, sustains quantum states for hours, and operates in living cells?